Hey everybody, Greg Thiessen here. Today I'd like to show you how easy it is to start a design project and manage your part data with XPM, our Expert Part Manager. As you're watching along, I'm also curious to hear if you've run other softwares, what the process you had to go through with those other products was and how it compares. So I guess let's just get started. So you're going to come up here and you're going to use our XPM, Expert Part Manager. You're going to give your project a name. So we'll call this XPM Demo. You can start with our standard design template, or of course any company or any individual can set up their own. How many cavities is this project? For our example today, it's only going to be 2, but of course you can do multi-cavity, you can do multi-material, multi-station molds, all different kinds of things. We're going to use 11.5 shrink, and that's going to automatically expand the part data for our project. We're going to pick our first version of the part, so we've got these V1 parts. You can import any file type you wish. And of course you pick all the part data at once. You're not limited to have to come back and reselect a second cavity. If you had 20 cavities, all different parts, maybe a family mold, you would select all of those right now immediately. We're going to let that import. So it's doing some processing right now. Now we're going to define the first cavity. I'm going to switch the background to black, just a little easier for me to see, and shade the part. It already is automatically looking for the largest solid in the file. Not always the part data, but very often it is. And you can see that it selected the part data correctly here. So all I have to do is accept and tell XPM that yes, you've correctly selected the part data. Now we are going to pick the tip point location. It's optimizing based on the center of the mass of the part. In this particular case, I want to move it over to where this drop position is going to be. For a round part, you might want it at the center of the round, maybe at a bottom flange, but that didn't happen to be center of that particular part. You're free to move this wherever you want. Notice that when it did select a location, it picked the center of the mass, but it ensured that it made it a nominal location. So of course in mold making, in particular die design, that type of thing, we do like nominals often. So it automatically had done that for us. We're going to accept that, and now we can adjust our die draw. For die draw, this particular part, the part designer gave us a vector that we are to use. We don't have to use that if we've got a flat or if we've got a boss. We could pick the bottom of this rib structure here that is a flat planar to the perpendicular to the die draw. You can also pick sleeve boss locations, any vertical edge of the part if there was no draft, say. There's many different scenarios or many different things that you could pick in order to accomplish the die draw of the part. Also, if this is a part that it has a complex tip and you had to do some manual work to figure out what that be, this would be the time that you could turn on your levels list and you can create levels past the XMD, say in the 1000s, and do some manual work and investigate what you want that die draw to be. Draw some lines, make a solid bounding box, that sort of thing. In our case though, we can pick the vector that was supplied, and you pick the base of the vector, and the die draw will go away from the end that you pick. So you'll see that it's automatically showing the vector there now, the die draw vector. So we're going to accept that. Now it's asking us to pick some seal off lines. So we can select and deselect anything that's not a seal off line. Action vectors, some graining area, and it noticed that there was nothing left in the file, so it automatically jumped to the end. Now we're on the second part file, the second cavity. It automatically noticed the part orientations in each of their individual files. It noticed that this is a left-hand version of the right-hand part that we had already defined. We have the part is already selected and ready for us to say, yes, this is the part data. because of the fact that it sees the parts are right hand, left hand scenario, it's already reset the tip point location, even though we had moved it to the location that we had picked on the first part. And it's already set the die draw vector where we had positioned it. So we can just accept through these things. They're already as we want them. Again, I'll switch the background to black. We'll select and deselect things that are not the CLF lines. We'll select the vectors and a graining area that we have. Now notice how XPM automatically reoriented those parts, automatically put them in a two cavity position scenario. It's established a certain amount of steel around the parts and between the parts, all automatically. The user doesn't have to sit and move things around or adjust. Now, of course, we are free to use dynamic move here, just a right click on this little graphics screen. We can rotate, we can edit, we can do many different things. We can point to a different part. If we only received one of these part files and we knew that it was a right hand, left hand, we can make a copy and define it on the other cavity or on the other cavity location. So, and then when the true part data comes in, we can simply swap with the correct part data. So there's many different things that we can do here. We're going to start mold. So we come to the mold base editor screen, and you can key in a job number. And you can set up, which you'll already have a config defined for your particular company. You can also edit the title block. If you had a standard mold base, you can assign that now. Select plates that you wish to have, orientation, all that kind of thing. What steel material are you using? This is going to be a high hard P20 job. Of course, it can be stainless or H13 or anything else. And we're going to say OK. You'll notice that XMD doesn't use any kind of predefined template. So for every mold and every custom mold that you are designing or that you're starting, it's going to evaluate the amount of steel that needs around the parts. It's going to evaluate the size and quantity of eye bolts, assembly screws, all the kind of safety factors associated with building a mold. The engineers don't have to do that anymore. That XMD takes care of all of that. The number of ejector screws throughout the plates, all completed for you. It doesn't matter if your mold's 10 inch by 10 inch or if it's 100 inch by 37 inches. It doesn't matter. It's all taken care of for you. So we've got the original parts in this job, but now the customer, we've gone for steel approval, and the customer has a revision to the part data. So now we need to swap in new part data. So I'll show you how easy that is to do now. You come up and you select in our design navigator, select on the cavities. We're going to swap both parts. Right click, swap part. So we're swapping out the right hand V1 for the right hand V2. And the left hand V1 for the left hand version 2. So if I open the levels list and show you here, this blue is the new part data already swapped in. XPM has interrogated the file enough to see that, to determine that that is the new part data. And if I open this up here, it's showing the obsolete part data so that the designer can actually turn it on, do a little interrogation, make sure that the customer called out part changes are exactly what they see. And then when the file is all complete, we're satisfied with everything, we simply say save and close, and it will actually delete this obsolete part data from this file and clean the file up for us automatically. So we see here that there's a raise in the part, and that's all fine. That looks good, so I can turn that off. Now there are other items in the file that it hasn't sorted for us, and we can decide if we want to keep them or not. So here's our previous, tip point, seal off, vectors, and here's the new part file. It has also some parting lines shown. So if we compare the parting line, seal off lines, and now maybe the seal off lines for our job, we actually want to make them thick. Then in the job they'll show up a little bit better. And I'll make the lines in the new file a different color so that we can see and we can compare a little bit better. So you're free to do any kind of manual changes you want to these files. You can set the entity attributes as you wish in order to interrogate the file a little bit better. We'll look at the actual seal off lines. These happen to line up exactly, of course, so we're not interested in moving anything. We'll keep what we had. Our file looks good. We've got the new part data shown. It's already applied the scale, the shrink factor for us automatically. There's no human error allowed. Everything's done very nice and quick for you. And we'll say save and close, and we'll go on to the second file. We're just going to tell it to delete the extra unsorted geometry that we already looked at and we don't want to keep. So we're going to say delete that. And notice that the same conditions apply to this job. And everything's updated. So that's both cavities completely updated. Now the great thing about the previous data is it never goes away. So if I turn everything off and I open up cavity 1, this is our new data. But we also have access to any archive data directly in the design file. So if we're in, say, a design review or some kind of meeting and somebody needs to see what the data looked like before, we can turn that on. And we can compare that to the parting lines or to any molding features. So you don't have to go to your server and bring it back in. Everything's always available. And it doesn't slow down the design file at all. Everything's in assembly and it's just sitting accessible in the folder. There's no repercussions. All right, so that's exactly how we have built the XPM. Again, please, below I'd really like to hear how you've had to do this work in another software, and let me know what you think about what we've built here. All right, thanks a lot.